Hi everyone, welcome to the Function Junction, where we make math simple and easy to understand. Today we'll learn how to solve systems of linear equations by elimination. In our last lesson, we learned how to solve systems of equations using substitution. Substitution works really well when one of our equations already has a variable by itself. But what if neither equation is written that way? Do we always have to rearrange an equation first? The answer is no. Today we're going to learn another powerful method called elimination. Instead of replacing one variable with another expression, we're going to make one variable disappear completely. By the end of this video, you'll know exactly when to use elimination, why it works, and how to solve systems step by step. What is elimination? The goal of elimination is exactly what the name suggests. We want to eliminate one of the variables. Notice these two equations, x plus y equals 10 and x minus y is equal to 2. The first equation has a positive y. The second equation has a negative y. Those are called opposite terms. When we add these equations together, positive y and negative y cancel each other out. That leaves us with only one variable to solve. So instead of solving two variables at once, we've turned the problem into a simple one-variable equation. Why does elimination work? This method isn't a shortcut or a trick. Each equation represents a true mathematical statement. When we add two true equations together correctly, the new equation is also true. We're simply combining information from both equations in a way that makes the problem easier to solve. Let's take a look at our first example. Find the solution for the following lines using elimination. Y plus x equals 10 and x minus y is equal to 11. Step 1. Arrange the equations. Always line up the terms. Place the x terms under each other, the y terms under each other, and the constants under each other. This will make it easier for us to combine like terms. Step 2. Add. We can add both equations together to get x plus y plus x minus y equals 10 plus 2. Step 3. Solve. We can see that the y values cancel because they are opposites, leaving us with only one variable to solve. We get 2x equals 12. We then divide by 2 on each side to get a value of 6 for x. Step 4 is to substitute. Using the first equation, x plus y is equal to 10, we can plug in the value we found for x into our equation. We get 6 plus y is equal to 10. We subtract 6 from each side to get y is equal to 4. Step 5. Check our answer. Using the second equation, we can plug in both our x and y values that we found, and we get 6 minus 4 is equal to 2. Therefore, our left side equals our right side, telling us that our answers are correct. Therefore, our ordered pair is 6, 4, and it satisfies both equations. Let's take a look at another example. Find the solution for the following lines using elimination. Y plus 2x equals 11, and 3x minus y equals 14. Step 1. Arrange the equations. We can rearrange the equations to line up like terms. Step 2. Add. We can add both equations together to get y plus 2x plus 3x minus y equals 11 plus 14. Step 3. Solve. We can see that the y values cancel out again because they are opposites, leaving us with only one variable to solve for. We get 5x equals 25. We then divide by 5 on each side to get a value of 5 for x. Step 4 is to substitute. Using the first equation, 2x plus y equals 11, we can plug in the value we found for x into our equation to find y. We get 2 times 5 plus y equals 11. Subtract 10 from each side to get y equal to 1. Step 5. Check our answer. Using the second equation, we plug in both their x and y values that we found, and we get 3 times 5 minus 1 equals 14. Therefore, our left side equals our right side, telling us that our answers are correct. Therefore, our ordered pair is 5, 1, and it satisfies both equations. Why did elimination work immediately in the two examples we just did? It's because one pair of variable terms were already opposites. This won't always happen, and that's where our next example comes in. Example 3. Find the solution for the following lines using elimination. Y plus 2x equals 8 and x plus y equals 5. Step 1. Arrange the equations. we can rearrange the equations to line up like terms. Step 2. Add. We can add both equations together to get y plus 2x plus x plus y equals 8 plus 5. Step 3. Solve. This time, both y values are positive. If we add them together, they become 2y. Nothing disappears. So before adding, we need to create opposite terms. Let's go back to step 1. Multiply the second equation by -1 to get negative x minus y equals minus 5. It's important that we multiply every term in the equation by -1. We can't multiply just one term. Now we can proceed with step 2 and add both equations together. We get 2x plus y plus minus x minus y equals 8 minus 5. Step 3. Solve. We can now see that the y values cancel out again because they're opposite, leaving us with only one variable to solve for. We get x equal to 3. Step 4 is to substitute. Using the first equation, 2x plus y equals 8, we can plug in the value we found for x into our equation. We get 2 times 3 plus y equals 8. We subtract 6 from each side to get y equal to 2. Step 5. Check our answer. Using the second equation, we plug in both our x and y values that we found to get 3 plus 2 equals 5. Therefore, our left side equals our right side, telling us that our answers are correct. Therefore, our ordered pair is 3, 2, and it satisfies both equations. Let's take a look at some common mistakes students make that can be avoided. Mistake number 1. Multiplying only one term instead of the entire equation like we saw in example 3. Mistake 2. Adding unlike terms incorrectly. Mistake number 3. Forgetting to substitute back to find the second variable. And mistake number 4. Not checking the ordered pair in both original equations. Let's summarize what we learned in today's lesson. First step is to write both equations in standard form if needed. Then, look for opposite coefficients. If necessary, multiply an equation to create opposites. We then add or subtract the equations. Next, we can solve for one variable. We can then substitute back to find the second variable. Lastly, we check our answer. Congratulations! We successfully learned how to solve systems of linear equations by elimination. If you like this video, make sure to subscribe. Also, make sure to check our other videos to continue your function junction journey. See you next time!